All right, good afternoon, everybody. Welcome back to another live stream. So today we are taking a little bit of a detour from the mini series that we kicked off last week around DSP. I say a little bit of a detour because it's not a whole detour. In fact, this is actually still quite relevant to DSP. It's just not exclusive to DSP. And so, what do I mean? So, the title of today's stream is what did I call it? Integrating a custom API interface with LiteLLM. So today, we'll cover the concepts of what LiteLLM is and why this is important for DSP and other frameworks. And then usually what I do is I share the code like immediately right out, like the correct syntax on how you do this. I am going to do that, but we're going to take a little bit of a different approach, just specifically because like I found this to be an extremely confusing and challenging thing to get integrated with. All right, so let me go ahead and share my screen. We're going to just hop right into things today. Okay, so what you are seeing right here, this is the LiteLLM website. And so let me see if I can make this right here. So holistically speaking, this is what LiteLLM is. Actually, this little graphic that they have here is actually quite good. So LiteLLM, basically, it is not an LLM itself, to be clear. It is like this server, if you will, or this conceptual server. We'll talk more about that here in a little bit. But it's this means where a user can authenticate with this centralized thing, and then within the centralized thing, you can have extra things like cost tracking, as it notes, batches, guardrails, etc. And then the idea is that you can also connect, like these LLM endpoints from all these various services, so that when the user interacts with LiteLLM, then they don't have to go changing around their syntax or anything. So this is actually very similar, conceptually speaking, to like LangChain. So like in previous streams with LangChain, what we've covered is like when you instantiate any of these model objects, whether they be an OpenAI or an Anthropic model object, you can call it like sort of the same way. The big difference here is that LiteLLM is trying to do this at a server level, instead of like I would say like LangChain's not really a server. Maybe they've added it. It's actually been a little bit since I've checked out what LangChain has added, but LiteLLM is more of like a server base. So you might be wondering, well, why is this relevant to DSP and why is this relevant to our stuff? So recall that what I just mentioned, that like when a user calls into this LiteLLM service, you can see that it goes off to these different paths. So this is relevant to DSP and these other frameworks, is because DSP specifically has chosen to make use of LiteLLM as like the framework, if you will, to be able to call the various large language models. So in fact, let me just show like the DSP website here. So when you come to DSP's website and you want to set up your language model, you can see that this was the one that we used last week. We just used the standard OpenAI syntax, so this is all pretty straightforward. And then you can see that there's a couple of other options here. And then you can see when we actually sneak on over to the other provider section here, this is what they're intending to, how to make use of LiteLLM. Is like, let's say like you were trying to make use of one of these other sorts of providers, then it's supposed to kind of abstract that away, if you will. So this is all pretty great when it comes to things that are already like managed by DSP, or I'm sorry, not DSP, by LiteLLM. And what I mean by that is like, so you can even see here by the icons, they have these built-in providers already. Like if they're a big company, they already have one of these connector things that you can already make use of. So that's great. But let's say I come along with a custom API interface, like it is maybe something I've stood up internally for my company. Maybe it's some sort of other proxy server that you're wanting to make use of. For our purposes today, I noticed that because I don't have like a custom API myself that we can make use of publicly, we're going to use MLX. And to be clear, I actually am not going to recommend MLX for DSP, and you'll see why in a little bit. But I just want to use MLX as like our sample framework to kind of demonstrate how we would enable a custom endpoint. So like I said, we are going to approach this in the way that, as if I'm approaching this for the first time. We will show the final code in the end, but this is really just to show all the little gotchas that I kept running into with LiteLLM. All right, so if we want to go and look how to do this, we need to jump on over to their docs here. All right, so this is their documentation. Oh, I guess I should have called out here. So So with the LiteLLM framework, like, so this is what they would refer to as their proxy server. So basically, this is serving as a proxy. This is an actual server running on some sort of computational hardware, but you don't necessarily need to have a full server proxy server up and running to make use of the custom interface kind of thing. And so for our purposes, like with the MLX purposes, like all I need is like this framework that basically takes my inputs, packages them up in a way that LiteLLM can make use of them, and then sends them on to MLX. I don't need a proxy server. So we're not even going to touch necessarily the proxy server stuff today. The only reason I wanted to call that out is actually if you go to their website here and you go under the proxy server settings, if you want to see an example of what the proxy server UI looks like, they actually have this demo app thing here. And so then you can go over to their demo UI. So this is their demo UI. I think they put the password. So admin sk1234. So let's go ahead and do admin sk-1234. All right. And so this is going to be like give you a flavoring of like what the proxy server looks like if you choose to go this direction. Again, we're not going to really cover that in this stream because this is not really a concern to me. But I just kind of wanted to show you that like if you do want like. I appreciate that LiteLLM has put this demo out here. So that way, for anybody who wants to just go and look like, hey, what does this user interface look like? Then you can, boom, just go right out here. Don't even have to worry about setting this thing up yourself. And again, we are not really going to touch that for this stream. So I want to let me just come back to the high level documentation here. Yeah, so this is like the front page of the documentation here. And then you can see that, it notes that we can call hundreds of LLMs using the OpenAI input-output format. Remember that. I'm not going to tell you why to remember that right now, but keep this in mind. It just says you can call 100 plus LLMs using the OpenAI input-output format. Okay, interesting. And so then you can see that it's got like the Python. We talked a little bit about the proxy server, and they do have a Python SDK, so we are going to be making use of the Python SDK. And so as you keep scrolling down here, you can see how it encourages use of like various models, but you'll notice in here that it does not have like a custom thing in here. So if I wanted to do a custom thing, so I'm just going to keep on scrolling down, looking for it. Okay, so it's not on this page. All right. So let's go on to, let's look up on the side here. So off on the side here, we got a bar of options. Maybe it's under guides. Maybe we can find something under guides on how to set up a custom endpoint here. Okay, so I don't think any of these look right. Yeah, none of these look, okay, so none of those look right. What I'm getting at here is that there's basically no documentation on how to do this. Like I actually did find the true documentation, and I'll show it to you right here. So it's actually under supported models and providers. If you go to here, and then if you come down, you can actually see, all right, here's the custom API server format. And then this is the example that they give. So the example that they give is actually calling GPT 3.5 Turbo. And then you can see also that like it's using this custom provider map thing to actually register it. All right, so now that I've gotten a sense for this, the first thing that we need to do is we first do need to emulate our API, if you will. So fortunately, MLX offers a really simple implementation of that. So just for context, so I am streaming today on my MacBook Pro. I've been streaming on the MacBook Pro for years now. Some of you might recall in like the earlier days of the stream when I was like exploring MLX that I had this problem where if I started up something with MLX and it went wrong, then it could eat up all my RAM, which was a problem when I was streaming here because then it would kill the stream here. So good news is now I have a separate Mac Mini that I basically use as a coding server. So I'm still streaming on the MacBook today, but I'm gonna host the server on my Mac Mini over here. And the great thing about I'm so excited about this because for future streams, now I can be a lot more free to test things out without worrying about like the stream bombing out because now it's not totally tied to the exact same thing. So anyway, let me go back to sharing my screen. So so over here is I'm still on my MacBook Pro here, but I have SSH'd into my Mac Mini over here. And so the way that we can start up the MLX server is so it's this you have to do the pip install the MLX-LM, apologies, and then you have to set a couple of these configuration items. So we're going to set the host to be 0.0.0.0, port to be 8085. I actually found that to be important in the sense that like you don't have to land on port 8085 specifically, but I noticed that a lot of demo frameworks use like port 80 or I'm sorry, port 8080 or port 8000, and I actually did test this out on port 8080 and port 8000. I don't know what was going on there. Maybe something else on my Mac Mini was making use of that port, but it just wouldn't work for me. So that's why I switched it to this other custom port. And so we can actually go ahead and start this up here like such. Okay, we'll just give it a second. So now to start it up, and so in order to invoke this, then we actually have to call it just like we would like any other like API. So I actually do have all right, how do I want to do this here? Okay, so what I'm going to do here is we're going to go over into here, and I'm going to just right now I'm just demonstrating how like the LLM API works. So like I mentioned, so I'm on my MacBook Pro here right now, meaning that I have to load in my IP address. So what I did was I saved that to a local file, so that way I'm not exposing that. So I'm going to do with open, and then I'm going to go up to directory API key or keys IP addresses .yaml as f Hundley Mac Mini IP equals YAML safe load f, and then I think I actually have that. I'm just going to copy and paste this. I don't know why I did that. All right. Sorry, just reformatting some things here. Okay, I didn't even do any of my pip installs, but any of my imports today. Here, let me make this bigger for y'all, so just in case it's too small. By the way, I am taking questions across LinkedIn or YouTube. I still don't know how to do the stuff on X, but so if anybody has any questions, feel free to drop them in the chat there. Import YAML, import request. So request that this is the standard Python library that we use for like to basically emulate curl commands, if you will. And then what else did I load in here? Okay, it looks like it was just these three. All right, so I loaded in the IP address. Now let's set the URL. So the URL is going to be, URL is, it's actually going to be this. So the nice thing about the MLX server over here as it manifests is it's actually already been written to return things in an OpenAI-like format in response. And I guess the one thing well, I'll get more into that later. So anyway, so that's how we set that. And then what else do we need to do? We need to set our headers. Okay. Header equals, all right, content type, application/JSON. Okay. All right, and then I need to set my payload. Payload is going to be, all right, messages. All right, so messages. I don't even know why I'm trying to type this because some of this doesn't even matter. Like I'm just trying to highlight like how you actually call this. Generally speaking, this isn't even relevant to LiteLLM, so I'm just gonna copy and paste this then. And apparently I didn't copy the headers. All right, there we go. All right, so let's just quickly run through this. So again, we are loading my IP address from a local file just because I don't want to expose that. Then I am setting the URL, and then so if you're not familiar, like the way that OpenAI works with their API is they follow this standard sort of nomenclature in terms of like being able to evoke their primary ChatGPT models. So then we're setting our headers. This is nothing new for any sort of curl command. Setting our message. In fact, I'm going to say. What is the capital of France? And then France, question mark. And then, so what should happen here is that when we run the cell, it notice here that there's like no other like post calls or anything. So let me go ahead and run this. Sometimes it takes a little. All right. What you saw there, like if you were wondering why it took so long to run there, for some reason, I've just noticed that in VS Code, whenever you start up a Jupyter Notebook on a kernel, like it just takes a little bit for the first time. So actually, if I were to run this, like what's the capital of France, what's the capital of Illinois, let me change this. And just to show you, like it's already, you can see that it's already made 1 successful call here. So when we run this again, we should see it. We should see another one here, and you'll see that it should run more quickly this time, or maybe not. Okay. It was about 3 seconds. I mean, that's about expected. So this is, again, I guess I should have called out here that I am making use of the Mistral 7B 4-bit model. I could have used a different model here, and we'll talk a little bit more about why I would not recommend MLX for DSP necessarily. We'll get more into that later. But anyway, so it is producing the responses. In fact, so let me see. Let me scroll down over this way. Yeah, so you can see where does it say? It gave us Mistral 7B tends to be a little bit chatty, so it gave it, yeah, capital of Illinois, Springfield. Is located approximately 200 miles southwest of Chicago, which is correct. And then it's in Sangamon County, et cetera, et cetera. And then you get like all, but if you notice, like this whole response object here is very much formatted as if it is like an OpenAI object. So I'm just going to paste it in here just to kind of make it a little bit easier. And I think that's kind of cool that it even shows like the, you know, the Apple or the Apple hardware details that it's running on. Okay, so we've successfully made this work. So let's go back to our documentation here. Okay, so according to our documentation here, all we should have to do really then is replace this with like what we would expect to get back from the model. All right, so let me just go ahead and copy all this. All right, I'm gonna put this in this new cell down here. All right, now let me read through this because it's been a little bit since I've looked at this. Okay, so the thing I want to call out here, and this is actually not a horrible example, but it could be so much better. So what you have to do here is, so you can see that within the LiteLLM Python SDK, we have this custom LLM object, and then we are basically creating a custom class out of that. Instantiating an instance of that custom class, and then LiteLLM has this thing called the custom provider map. So coming back to this visual over here, so recall that we have, when we register like our various models with LiteLLM, what it's doing is like you actually use a if you're standing up a proxy server, you use this thing called a configuration.yaml file or a config.yaml file, and then you basically just say, okay, here's all my different models that I want to enable, and essentially, that is what this is doing here. It's just that it's baking it directly into the Python code and not making use of a config.yaml file. And so you can see here within the custom provider map, we do have to say, okay, this is my custom provider, and then this is my custom model, and then this is actually how we invoke it. Now you might be wondering, well, where does this name come from? Like this my fake model thing? That's just it's just kind of like a little bit of a LiteLLM gotcha, where like, so like when it comes to like any like LLM model, like typically they are named as like company name / model name. And you can even see that here with, or well, I guess company name's not even fair, but community name / model. So you can see here that with the Mistral 7B, I'm actually grabbing this from the MLX community up on Hugging Face, and then it is within here, like manifests as this specific model name. So we do need to provide that as like sort of a, I don't know any other word to say it, like we're fooling LiteLLM into believing it is actually interacting with something like one of these other models. It's just that this string here actually never comes into use at all, which can be strange. Okay, so let's see. Let me look at my other code here. All right, so let's say I actually wanted to update this completion here to make use of LiteLLM, or I'm sorry, to make use of the MLX server here. So what I'm going to do is I'm just going to copy all this stuff here. And so what we should have, what should happen here is, so, okay, so instead of doing a request.po, like this is all my custom code here. And so I'm going to replace this because it's doing an actual LiteLLM completion. I'm going to return, so it wants to see a model response object. So that's what the syntax kind of here is indicating is here's our inputs, and then here's the expected output. So let's try to make this into a model response object. So we're going to say, in fact, actually, I need to look at something here. I want to see how this is actually formatted. Oh, wait, I guess I pasted it right here. All right, so what do we need to grab out of here? All right, so we need to grab, in fact, I'm going to make this just like a standard JSON object. I'm going to just call this new file test.json so it's easier to read. Well, it might help if I formatted it correctly. Format this into a 4-tab JSON file. hope it'll do. I hope it knows what I'm talking about there. Okay, it looks like it's doing what I wanted. Well, I didn't want all the log probs like that, but okay. All right, so but this is a little bit easier to read now. All right, let's give it a second to finish processing here. Okay. All right, are we done then? Accept. Okay, so now we can see that, all right, so we need to go into our choices. We need to, all right, and then choices is a list, and then we need to get the content specifically. Okay, so what I'm gonna do here then is I'm gonna come here. In fact, I'm gonna split this off to the right so I can have a reference. Okay, so let me come back to here. All right, so recall that I've got this response object, so I need to be returning a model response, LiteLLM.model response, right? Because that's what is expecting to get back. All right, and then it, all right, so what do we, all right, so where is this model response? All right, what do we need to return all as part of the model response? We need to say, all right, so model is going to be MLX. I don't know, doesn't really matter. Messages is going to be, what is it? Response dot, it's one of these things. All right, here, let me just do this. Response dot JSON. Oh, thank you. Wait, why did that? Choices, maybe? Choices? Okay, there we go. This is what I want. This is the little bit of text thing that I need. All right, so we should, all right, so messages is going to be, oh, how is that formatted? Content. Or I'm just going to say, yeah. Yeah, all right. Okay, I think that looks fine. Response, mock response equals hi. All right, so let's just go ahead and try to test this out and see what happens. All right, I'm gonna close that out. If this actually works, I'm gonna be so mad. Okay, all right. So we see problem number one is that like the, well, I don't know why it, here, let's see what RESP. Yeah, I didn't want that assert statement there. I don't know where that came from. No way, did it really just work? Okay, so it, I can't believe it actually just kind of, wait, no, it didn't. No, it did not, because it's still saying the capital of Illinois, Springfield, and where did it get that from? And do I still have some print statement up here that's printing something? Oh, that's because I have the payload here as such. Okay, so I actually do, what I need to do, next thing I need to do then is I need to refactor this. So all right, so when we actually make use of this completion object, we need to be able to get the content out of here. So how do we do that? So let's go to their documentation and see how we might do that. Oh, okay, so it does not show it in here. I'm probably being overly harsh, but like it's very frustrating when the documentation is not kept up to date. And so I'm just going to kind of jump to the end a little bit. So I mentioned earlier on, remember that it says call 100 plus LLMs using the OpenAI input-output format. The way I understand this isn't just like a nice to have. This is a firm requirement, meaning that when you actually create your input, like whenever you create a custom interface for LiteLLM, you have to make it look like it's going to work with the OpenAI interface. It doesn't say that anywhere in here, but I actually worked on this with some other colleagues, and they noted the same thing. It's like they could not find anything in the documentation about it noting that it happened to be an OpenAI interface. However, nothing worked unless we did it that way. So your temptation then might be, well, I would say, all right, so let's say I want to use generative AI to help me out. So I'm going to say, I'm going to copy this whole thing, and I'm going to go into ChatGPT, and let's use O3 Mini High, and I'm going to turn on the search capabilities, and I'm going to say, help me fix this code so that it properly works with MLX LM as an API and LiteLLM as a holistic framework. Okay, so I'm going to go ahead and paste that in here. All right, let's see what sort of response that we get back. All right, because we are making use of O3 Many High. It's using this is a reasoning model, so it's going to take a second to fix this. Okay, and so, all right, let's see how it did here. All right, so it did all this fine. So let's go ahead and copy this and see what happens. All right, copy. I'm gonna go ahead and delete all this out. All right, let's go ahead and print out that response. Okay, a new response. So it is refusing to connect now. And I don't know why so let's check up here to make sure that we're not getting a connection error just from my Mac Mini. That could be a me problem. So nope, we can actually still connect through here just fine. And so what is going on here? Well, I don't actually quite know. Oh, so it's trying to make use of this 127.0.0.1. When I did not want it to use that, I wanted to make use of my personal IP address. Oh, that's because there was hallucination here. It decided to go ahead and fill in its own IP address here. So this is another O3 Many High has been the most frustrating model I've ever worked with because it constantly does things like this. So, all right, so let's see if I take that out. Maybe I got to rerun. Well, let me go ahead and try this again. Okay, so then we'll see if we can get a response here. Okay, so we actually did get a response that time. Let's see if it actually gave us... Okay, so it actually did give us a correct response. So, all right, so there's that. So let's go ahead and try this out with DSP and see if this is going to work with DSP. So what I'm going to do over here is I'm going to go ahead and grab another example of something that I've already set up here. All right, so I'm going to just grab this. This is just sample boilerplate code. This is actually code that we ran through last week. So let's go ahead and try to make use of DSP here. All right, import DSP. LM equals my custom LLM. Recall that this is how we configure DSP. All right, so let's go ahead and run this. No LLM is loaded. All right, so let's try to figure out what is going on here. No LLM is loaded. All right, so let me go back and check my code. And I'm not too worried about this, to be clear, just because I know this is all like not ideal code. I'm just trying to show you, like, when you try to go and enable this thing, like, I'm going to give you the correct code in here in a minute, but when you try to use generative AI or like look at the documentation, you will want to tear your hair out. It has been such a frustrating experience. Okay, so that did not work. It's saying no LM is loaded here. Let me check my code here again because it should be registering. Oh, I see what happened. It's because my custom LM. Oh, that's because I didn't call this right. My custom LLM. Okay. All right, so that was not correct either. Let me go down to here. Okay. Here, let me replace all this code. All right. What was this class object called? My custom LLM. All right, so I'm gonna put this here. Okay. I guess I'll import DSP at the top here. And then I'm gonna move some of this other code back up into here. Apologies. Just trying to show you everything that I had to go through to get this working. Okay, so actually that part did work. I'm gonna be so like frustrated if this actually works, like the first try, because I've spent like a collective 8 hours trying to get this working, and was like, in fact, I'll even just show you, like when I tried interacting with LiteLLM in other ways. So like the one thing I wanted to show you that like it's not showing for me is like it kept hallucinating, and it's not just O3 Many High, it was the other models as well. It kept hallucinating that where we have this thing, the register, the custom provider map. It kept acting like this thing called register provider exists. And so you could see, like, when I give it this prompt here, you'll notice there's nothing but hallucinations in here. So you could see that this is not how you make use of MLX LLM. You'll see nothing about LiteLLM in here. You will see, so these are like all incorrect hallucinations. And it's just frustrating. I even said, like, I've never actually gotten this mad with an AI before. All right, so it tries again. I said, like, this is completely wrong. Go back and look at my instructions. And my instructions are very clear. I want to make use of LiteLLM. And so after I say, no, this is completely wrong, then what do I get? Basically the exact same thing. No LLM or anything. So that is just, be very leery when you use generative AI for this sort of thing here. Because and then the documentation here, like there really is no documentation. And so the other people that I've worked with who have gotten this to work, we've all gotten it to work in different ways. But none of us are really satisfied with how we got it to work. So let me just show you. So let me see, like, that actually did work. I want to get another snippet of code out of here and see if, like, this is going to work. So this is the same. This is the same thing that we covered in our stream last week. It was just demonstrating how we make a custom signature with DSP. So let's see if this is going to work. Okay, I forgot that they cache responses. All right, so let's I think DSP caches responses, so that might actually be why. Yeah, actually, you know what? That might actually be why this seemingly worked, because of the cache responses. So let me change these up. So change the sample text here. Do not change the variable names. All right. So that might have actually been why it appeared to have worked, but it may not have actually worked. Okay, so you could see here, connection aborted, close without response. So there's another problem there somewhere that I'm not really sure what is going on. So if I were to go and update these, update the sample text here, do not change the variable names. Okay. All right, accept and run. All right, so let's go ahead and run that. Oh, look, we got another API exception error. So and then the other thing as well is like, when you import this custom LLM, you can see that we have a completion object, but there's also not just that. Like, there's more than just that. Like, there might be a completion meaning asynchronous completion. There might be a streaming one, and there's just no example of that out here. Like, to be clear, like, I appreciate that they actually did get all these other ones good and working, like all these other ones, but trying to just enable our own is just such a headache, unfortunately. And so let me, I'm just going to kind of just skip to the end here, and let me just go ahead and show you the final code. All right, so this is, and it's a mess. Not really a mess. It's just, when we come back to the actual documentation here, it looks like it's, oh wow, yeah, so easy. So let me show you everything that I had to do to get it working. So I mentioned before, did I have an init class in here? Maybe that's the problem. I should have an init class. Okay, so there's problem number one here, is that, like, it didn't, whenever, well, I guess I don't know how much that matters. I guess I just use the init class over here to be able to, like, save my URL and such in a reusable way. But then I had to create a bunch of these custom functions in order to be able to, like, actually make sure that all my formatting was correct. Because that's the other strange thing, is when you want to make use of, like, for example, the Mistral models. So oh, you can even, oh yeah, here's the error, the exact error that I was just about to talk about. So this is the DSP server here. You'll notice right here where it says conversations must alternate between user assistant, user assistant, user assistant. The problem here is that, like, I don't please don't quote me on this. I might be speaking out of line a little bit here. I believe that it's Mistral and Meta that have, like, this special thing that requires a template like this, but other models like OpenAI that don't necessarily require it. So this is where, like, for example, LangChain came and abstracted this all away for us, so that way we can make use of both of the kinds of models without issue. with LLM here, we have to figure that out for ourselves. So let me just show. Okay, so this is the completion object. So this just shows every single key that like I actually had to explicitly ignore any key that it wasn't making use of. I had to process the messages. So let's go up to the process messages. So that is basically just a bunch of weird if else statements on making sure that the roles and the systems and the users were all set up correctly. I mean, you can see that there's a lot more to that I had to use to actually get this working properly than is shown here in the documentation. The documentation is it's lacking. It needs a lot more. Yeah. So yeah, and you can see here, like, yeah, it even, this is what I was talking about here, where you have like the A completion and stuff. This isn't very helpful. And so at the end of the day, I just basically had to force everything into the OpenAI format. And so the and to be clear, like I don't have like a biff against that. And if you're not aware, so OpenAI, so they have their API, but and the models behind the API, but like the actual API itself, if I'm remembering this correctly, is not actually managed necessarily by OpenAI. It is managed by this other API company, and I believe this API company also manages like some of the other like the Anthropic API and such. Don't quote me on this, please. But like the reason I note that is we're calling it the OpenAI API format, but it's really this other proprietary company's API format, and so it's not necessarily exclusive to OpenAI. So I don't have a biff of like having everything having to convert into OpenAI format, but like just be clear about that, or give us some tools that will make it a lot easier to do that. Yeah, so that's basically what all this code here is doing, is just basically just refactoring everything to make it look like it's an OpenAI thing. And so let's go back to it, down to our thing. You can see our payload, max tokens, etc. So then we can see, now we can post after we've done all that munging, then we can finally get a response from our object. But then we have to kind of do the same thing in reverse, where after, even if we get a successful object, then we have to go back and reformat it as an OpenAI response here, and then finally we can return the model response. And so if I run this from here, so again, I mentioned that like it's caching things behind the scenes, but if I were to run it here, let me go ahead and update the sample text to something different, keep the variable names the same. I could do this manually, but I'm so why would I do that when I have the model that can do that for me? Okay, except so let's go ahead and run, and then okay, so this actually did it run correctly. However, this is the other thing that I wanted to call out with MLX specifically. I only wanted to use MLX as an example today because this is just like this is one like clear thing that I could demonstrate to you all. But the reason I would not necessarily use MLX unless you had like a beefy one of those new Mac Studios with the M3 Ultra chip in it, then you might be able to make use of this. But you can see here we have a hallucination. So you can see here I'm trying to get the sentiment for each of these respective sentences. So this one, the new features in the software update are fantastic and very user friendly. Yeah, I would definitely agree that is a positive statement. Whereas the recent changes to the interface are confusing and frustrating. So these are obviously negative words. We should have seen a negative sentiment here. And that is what, and so again, if you are, I don't want to discourage you from using MLX with DSP, but in my system capacity, so my Mac Mini over here is just like the baseline one, M4 chip, 16 gigabytes of RAM. It can run models, sure, but they're not going to be the most performant models, and therefore we get hallucinations like this. So I'm going to say down here as well again, change out the sample text, but keep the variable names the same. All right. Accept and run. All right, so we will see here, it'll take a second to run, and then you can see here that we're actually successfully making our post calls over here, which is kind of cool to see. I really do. So on the MLX side, I actually think this is awesome. I actually was not aware that there was this server capability until yesterday. So I think this is really awesome that MLX has this capability here. So not a knock against MLX itself by any means. So yeah, you can see here that like we are again getting a little bit of hallucination here. So recall here that with our signature that we wanted like a word count and we wanted a type integer. So with our two examples here, this bottom was correct, but now within this other one, well, now we have this all this other goofy bit of text here. And I'm gonna that's a model thing, and I'm not really surprised to see that because in my testing with Mistral 7B in the past, by the way, I recently learned that it's called Mistral and not Mistral, which is why I'm now saying it correctly. So Mistral, it's a chattier model, so I'm not surprised to see that like it hallucinated in a verbose manner. But yeah, you can see now I do have MLX working successfully with this. And so again, I totally missed this point, but the other thing I should have called out here is this is not exclusive to DSP. So let's actually go over to back to the documentation over here. They did have a note in here of like partners, like not like partner, like where is the partners thing? It was just like a note of like all the different people that are currently making use of LiteLLM to support their framework. It's not just I guess the thing I just wanted to show is it's not just DSP. There's actually quite a few of them out there. So if you've heard of like Crew AI, for example, Crew AI is another framework that makes use of LiteLLM. There's a handful of others. I wish I could remember. In fact, let me just search DSP. Maybe it'll show up if I search DSP. Or not. Or not. Or maybe it was on this main website. I don't know. I just saw it like an hour ago, so I can't remember. It's somewhere out on this website. It'll show. But like, so I don't want to say that like this. So this, you know, you might be wondering, well, why can't I just skip all this? Like, do I really need this LLM thing? Not. I mean, for your own purposes, like maybe not. Maybe you don't need it. But if you want to make use of DSP, if you want to make use of Crew AI or these other frameworks, yeah, you do have to figure this out for better or worse. So I'm not knocking like the creators of DSP or nor like Crew AI for making use of this framework. Like, and to be clear, I think it will get better over time. And I think the thing that reassures me personally is that, so if you don't know what Y Combinator is a startup incubator based out of San Francisco, and like it's one of the most popular startup incubators. In fact, this is the incubator that Sam Altman, who is now the CEO of OpenAI, he used to be the CEO of Y Combinator. So I do have some confidence that like LiteLLM will continue to get better. It's just at the current moment it's frustrating. Okay, it's nice outside, and I don't want to be streaming anymore. I just want to go outside. All right, and that's really all I had to cover for today. So, anyway, so yeah, that's how you. I guess basically that was this entire stream was basically if you do choose to use LiteLLM, just be aware that you have to make everything in the OpenAI format. That's really it. And just be aware that if you try to use large language models, and I'm picking on O3 Mini High a little bit here, although it's not just with this effort. Like I don't get it. Like O3 Mini High has just been such a like it produces so many hallucinations for me. But I tried this on Claude 3.7 Sonnet, including the new reasoning mode, and I also got similar hallucinations around that .register_provider function thing. So just be aware that is an issue, which is strange because then I tried Googling that where the register provider thing, and like and maybe I just wasn't looking in the right place, but I don't see that ever existed. And so I would forgive the models if this thing was like a popular thing that LiteLLM updated it, but I don't see that this ever existed, which is very strange. Anyway, so I'm gonna call it there for today. I'm gonna go get some sun and enjoy the nice weather. So I will see. So I probably won't do a stream next week just because I've been really busy. But we will get back to our primary DSP stream series, like a continuation of the series, probably in the next 2 weeks or so. So with that, hope you all have a great day, and I will see you in the next one. Bye.